ContainerUi. Hello again everyone. Today I will tackle the topic of ContainerUi, the second most flexible UI component in my UI library. This class is very basic example of a layout system made using and rendered using React class. Developers can make their own layout classes to understand grid UI, box UI, slider UI and expanded UI. This container UI is very necessary. Each UI acts as box layout with simple rules imposed. The container UI can act both as a parent and a child. It holds initial state of sizes and applies rules to calculate the state of final sizes of itself and all its children. If parent of a container UI is null, then it is known as a window, otherwise it is a child container UI. Each UI represented is rounded rects, so it has width and height as a size parameter. To understand container UI, we need to understand the 4 parameters and 4 rules used to compute the final states of container UI from its initial states. X and Y are top left coordinates of the rectangle, while W is width and H is height of the rectangle. Size can be static, meaning already given, or dynamically computed on the basis of size of its parent, its children and sibling. W constant and H constants are Boolean values. If W constant is true, means the width of the container UI cannot be changed by the states of its parent, its children or sibling. Likewise, H constant is true, means the height of the container UI cannot be changed by the states of its parent, its children or its sibling. W per means the percentage of width covered by the child over the total width covered by the parent. Likewise, H per means the percentage of height covered by the child over the total height covered by the parent. These are the 4 variables that needs to be remembered. Note that a window container UI will always have a static width and height. The container UI holds child either in horizontal or in vertical direction or in both. These images shows parent storing child horizontally or vertically, or which can further be expanded to make a mixed layout. Story time. Long ago, a parent container UI with its children UI containers sitting on a mat watching basketball match. Match ends with victory, but parent UI is sad cause his legs are now hurting. Let's move on to another topic. Now, the rules that define the dynamic calculation of the sizes of container UI are given below. Note the rules only apply on child UI containers, and also note that the static sizes has higher priority than dynamically calculated sizes. As an example, let's say we define 3 children for a container UI, all having dynamic width and height. That is, W constant and H constant are false, so the width is only affected by the proportion of sum of width of each UI as shown in the figure. The first child and the second child has weight 1 and the third child has weight 2 for its width, and thus proportion of space first and second child will take is 1/4, while the third child will take 2/4 or 1/2 of the width space. While height is only affected by the percentage of height it takes, or H per variable's value, as in the example the first child H per is 1.0, meaning it is taking 100% height of the parent, while the second and the third child has H per 0.7, meaning they are taking 70% of total height of the UI. So now coming back to the rules, parent is holding the child in horizontal direction, then 4 different rules are applied on the basis of the value of W constant and H constant. If the child's W constant and H constant both are false, then the child's width is calculated on the basis of its weight and its sibling's weight, and the child's height is calculated on the basis of height percentage value or H per value. Next, if child's W constant is true but H constant is false, then the child's width is static and W property is used. Since child's H constant is false, so the height is still calculated on the basis of H per value. Now if child's W constant is false and H constant is true, then the child's width is calculated on the basis of its weight and its siblings' weight, while the height is constant and H property is used. Lastly, if both W constant and H constant are true, then both height and width are static and W and H properties are used. Now for the second rule, if the parent is holding child in vertical direction, then the role of width and height changes. There are still 4 rules defined by the W constant and H constant property. The first rule is, if the child's W constant and H constant are false, then the child's width is calculated on the basis of the W per value, while its height is calculated on the basis of its weight and the siblings' weight for height. Likewise, if W constant is true and H constant is false, then the child's width is static and W property is used, while the child's height is calculated on the basis of height, weight and its siblings' weight. Now if child's W constant is false and H constant is true, then the width of the child is calculated on the basis of its W per value or percentage value, while the height is static and H property is used. Lastly, if the child's W constant and H constant both are true, and W and H properties are used, since width and height both are static. These are the only rules defined. Now let's get to an example. In this simple UI setup, the parent contains 2 children colored in red and yellow. The buttons down here are for first children. Initially, both the child starts with default values of W and H constant are false. W percentage and H percentage both are 1.0, that is 100%. W weight and H weight are both 1 and width is 100 pixel and height is 100 pixel. The buttons include W constant and H constant toggle if pink means false and if green means true. So by default both W constant and H constant are false. The second row has labels for weight and height weight. The max value the sliders can represent for these is 1. The third row has labels W and H percentage, and the max value the sliders can represent is 1.0, that is 100%. Lastly, the fourth row has labels width and height. Static values means the static values of width and height of the container, and the maximum value these sliders can represent is 100 pixels for width and 100 pixels for height. Lastly, let's give you a demo. Here both W constant and H constant are false. Thus the width of the first cell is only affected by W weight property, and the height is only affected by H per value since no sibling is present in vertical direction. Now, if W constant is true, then the width of first child is only affected by the static width property, and the height is still being affected by H per value. Now if H constant is made true and W constant is false, then the width of the first child is only affected by W weight property and the height is affected by the static height property only. Lastly, if both H constant and W constant are true, then the width and height both are affected by static width and height property only. In this demo, if both W constant and H constant are false, then the height is only affected by H weight value, while the width of the first cell is only affected by W per property, since no sibling is present in horizontal direction. Again, if H constant is true, then the height is affected by the static height property only, and the width of the first cell is still affected by the W per property only. Now if H constant and W constant both are true, then the width and height both are affected by static width and height property only. Lastly, if W constant is only true and H constant is false, then the height is only affected by H weight value and the width is affected by width property only.
And thanks for watching. Don't forget to like, share and subscribe and keep yourself updated for new content.